This is an example of how to use SPSS to compute an analysis of covariance. We'll be using a data set that looks at Peabody picture vocabulary scores in kindergarten, first, second, and third grade. We're going to use an independent variable that's called family risk level. It's a ordinal variable. It's listed here. The levels that we were considering will be 1 through 4. We are going to be looking at differences in first grade Peabody picture vocabulary scores based on a Roche-Wright analysis. So these are scores that have special scoring capacities. Our covariate will be the Peabody picture vocabulary scores, Roche-Wright scores from kindergarten, which are listed here. So the first thing that we have to do is we have to determine whether or not a critical assumption of analysis of covariance has been violated. To do that, we go to Analyze, General Linear Model, and Univariate. We're going to make sure our dependent variable of the Peabody picture vocabulary scores from first grade is in the dependent variable. Our Peabody picture vocabulary scores, Roche-Wright scores from kindergarten are the covariates, and our fixed factor will be family risk. First of all, we go to Model, and we need to make sure that we click on Custom to make sure that family risk is there, the Peabody picture vocabulary Roche-Wright covariate is there, and then to get this interaction effect, which is the critical test, because we're trying to determine that the regression lines between the covariate and the dependent variable have the same basic slope for all different levels of the independent variable. So we have to get the interaction effect. To do that, hold the control key and slide down, and you'll be able to send both of those variables over. So if that was out of there, I make sure that both of those things are bold. I send them over. Then I click Continue, and I click OK. What we'll see is that within this ANCOVA output, we'll see this interaction effect. This interaction effect is essentially the test of homogeneity of regression. We want to fail to reject that. So the fact that our significance level is greater than 0.05 is good news for us. It means that we have met the assumption of homogeneity of regression, and we can use PPVT kindergarten scores as a covariate. If this value had been less than 0.05, we would not have been able to use the kindergarten PPVT scores as a covariate, because our lines would not have been parallel for regression between covariate and the dependent variable for each different level of family risk. Once we have established the appropriateness of the homogeneity of regression assumption, we can then go to Analyze, General Linear Model again, and we're essentially going to run the exact same setup that we ran to test homogeneity of regression, but instead of using the custom model that we had just run, we're going to run full factorial. Still has type 3 sums of squares, and we click Continue. We go to Options, and we send family risk over as the mean that we're going to explain. We have some options in terms of the type of mean comparisons. If you want to be very conservative, you can use Bonferroni. You can also use the least squares differences, least significant differences. Make sure the descriptive stats, effect size estimates, homogeneity tests are all clicked here, and click Continue, and then click OK. So the first thing that it gives us the unadjusted means for each one of the 5 groups of family risk. Later we will look at a modification to these Roche-Wright scores that include an adjustment for the covariate. We look at the homogeneity of variance test, and we see that we do not reject homogeneity of variance. That's an important assumption. So we move down and we look at our ANCOVA table, and we see that our significance value for family risk is less than 0.05, and this is the adjusted family risk. This is the adjusted effect after controlling for the covariate. So this tells us that there is a difference in Peabody Picture Vocabulary Test scores for first graders based on level of family risk after controlling for any differences that are occurring at in kindergarten on the PPVT. So that's an important finding. We see that the covariate is statistically significant as well. It's less than 0.05. That tells us that that covariate had an important relationship to the dependent variable. We see that we're explaining roughly 52.5% of the variance in the dependent variable of Roche-Wright PPVT scores for first graders based on family risk and also the kindergarten Roche-Wright PPVT scores. We look at the eta squares and they give us similar information. We see that family risk in itself is only accounting for about 0.8% of the variance in Roche-Wright PPVT scores in first grade. We see that the pretest, the covariate, is accounting for significantly more of that total variability in PPVT scores in first grade. We can look at our estimated marginal means, and you can see that they are different than the ones that we saw up here. See the mean, the unadjusted mean at family risk 0 was almost 97, and for 1 it was 94. We come down here and we see that these adjusted scores are significantly lower after adjusting for the differences in the kindergarten PPVT scores. Our pairwise comparisons help us identify where the significant differences are. And we can see that for family risk 0, there was a significant difference between 0 and 2, 3, and 4. There was a significant difference between level 1 and level 3 based on that significance value. Significant difference between 0 and 2 again, which is redundant with what we saw there in the beginning. And again, if we had used the Bonferroni correction in terms of finding these comparisons, we would have found far less significance because it's a much more severe adjustment of type 1 error correction. And that's the basic overview of how to do ANCOVA. You need to make sure that you test for homogeneity of regression before proceeding, because the consequences of violating the homogeneity of regression assumption for analysis of covariance can be quite severe. We need to find an alternative to ANCOVA if we have violated that assumption.